Sweet. So now we can jump into actual high-performance.NET with gRPC on Linux App Service, and I have Jeff here with me, who's going to be helping us out. We're going to start. We're going to talk a little bit about App Service, set some context. I know that you've seen it in a bunch of demos already today, but I want to make sure that everybody is thinking about it in the same mindset. And then I'm going to talk a little bit about how we use .NET on App Service itself to improve and power the platform. And then we're going to go into gRPC and the demo, and that's where Jeff is going to help us out and get this thing going. Okay, so let me get my slides up and ready. And then Haley, whenever you're ready, I think we can start sharing my screen. Okay.
Good to go.
So let's say that you're hosting a cloud application. It could be like car ownership, and this is like the silly little analogy that we use. So you have several options, right? On the one hand, you can buy the car and operate it, and if the engine falls out, it's your responsibility to go do something about it. And we think of that as infrastructure as a service, right? So nobody wants to wake up on a Wednesday after Patch Tuesday to go reboot a bunch of machines and apply security fixes. But if you're on the IaaS world, that's sort of the stuff that you need to do on top of the code that you're writing for your application. At the other end of the spectrum, you have things like software as a service. Think of it as like Office, right? You don't necessarily go and tweak Office, you just use the app. And somewhere in the middle, you have platform as a service, which is what App Service provides you, right? So the whole mantra around App Service is let the developer focus on their code, and we will handle the infrastructure and the platform so that your developer efficiency is on writing the code for your business that you care about and maintaining that and not applying patches, etc. Common scenarios is, we have everything from digital marketing, transaction, line of business applications, small applications, large applications. I think the largest engagement in which I've personally had something to do with is we hosted the CBC app for the Canadian elections, which did, billions of requests, and it had over 5 million concurrent users. So, it can go from hosting a side project to hosting, large world-scale applications over hundreds of instances and billions of requests. So, whatever it is, we can handle it. Now, we have this really close relationship between the .NET team and the App Services team, and we use a lot of .NET to build the App Service infrastructure in itself. One of the latest things that we've done is we've ported a bunch of code that was in our what's called the front-end role. So I'm getting into the weeds here of the details of how App Service is built, but it's important to understand. So the Azure load balancer is when your browser sends a request to Azure, that's the gateway into the data center. And then the gateway into App Service is this thing called the App Service front-end. You can think of it as a proxy that then directs the request to the actual VM where your application is hosted. And we're going to go and we're going to zoom into that. So the way this used to work is we had IaaS and we had a bunch of homebrew technology that was built by the team because a lot of the people that work on App Service used to work on IaaS before. So we were very familiar with IaaS. We were able to extend it and build those homebrew modules. But over time, it gets harder and harder to maintain if we're the only ones that know about that code and if we're the only ones that can go debug and fix it. So that's part of the motivation for adopting some of the .NET technology that is out there with .NET 6 and .NET 7. Specifically, we were looking at YARP and Kestrel. And we were able to basically remove and replace all of the code that we had in the front-end role with the new Kestrel and YARP modules. and take advantage of .NET 6 and all of the perf improvements that are built out of the box with that. A lot of people don't know that this actually happened. So this is something that we did at the platform level, where we went and we updated each and every unit of scale of app service across the world transparently, without you even knowing that this happened. On our side, the benefit is that it's a lot easier to debug and fix issues. When we were seeing that demo from the previous slide, from the previous session, where people were taking memory dumps and analyzing the code. The difference here is when we had to fix something with ht.sys on IIS, we had to take a memory dump of all of Windows. Whereas now we can just take a memory dump of the .NET process that is hosting our code. So it's really easy to narrow down and debug issues on the front end now. This also enabled us to build a bunch of new features, one of which is what we're going to demo now and what we're going to talk about, which is enabling us to provide support for gRPC at a platform level. Some other work that we're doing in this area is we're actually, again, from previous session, you saw a lot of demos on Kudu. We're working towards unifying the code base of Kudu, that we have one version of Windows, one version in Linux, and we're trying to get everything together, all running on .NET 6. So that's some of the stuff that the team is doing internally to use .NET 6, provide the benefits of .NET 6 forward into the customers. And then one final remark, because of the performance increases that we got from .NET 6 and moving to YARP and Kestrel, that means that we can run at scale with less of a footprint on the data center. This translates to several things. One, it's a greener service, because we need less machines to do the work that we were doing before. And it also allows us to have less capacity constraints, where we're not using machines for infrastructure roles that we could be assigning to customers for use for their code. So those are some of the benefits that we saw by moving to .NET 6. Okay, so let's change gears and let's start talking to gRPC on app service. Jeff, you want to take it away?
All right, so if you're not familiar with gRPC, it's a remote procedure call framework that streamlines messages between your client and server over HTTP2. And it does this by opening up a gRPC connection or channel between that client and server, which allows you to implement different types of calls. So you can do client streaming, server streaming, and bidirectional streaming as well. It also does this by using protocol buffers, which is where you define the service, and then that enables you to do language agnostic implementations. Now, how does it work on app service? First, the app will be configured to allow HTTP2 client request. Then that request is forwarded to the worker via the proxy. And lastly, app service requires an app setting port number that only listens to HTTP2 request. If you're familiar with app service, you can kind of tell that these look like config values that you'll need to set for your app to work with gRPC. And this is a list of the gRPC calls that are supported. So Unary, server, client, and bidirectional streaming. Okay, and now we're going to show the demo. We're going to show a deployed application, Unary stream example, and then also a server stream example. So if we can just switch to my screen. Right, all right. So here we already have a gRPC service application that's deployed on app service. And if we browse to the URL, it shows us a message saying that communication with gRPC endpoints must be made through a gRPC client. And then it gives you a link to go ahead and show you the instructions to create that client, but we already have one created locally. So we're just going to grab the endpoint and then go to our local client in Visual Studio. And we're going to paste that endpoint in the gRPC channel. And now the client knows where to actually create that connection. So if we start the app, and it's just a simple console app, and it gives us a message, hello from app service.net day.
So
So yeah.
in this case, this was an example of the Unary scenario, right? Where you send one request and then you get a response back from the server.
Yeah, exactly. So what's happening here is the client is sending that request, and then the deployed server is actually listening for this request on a specific port number that we set, and then it returns this message.
Awesome. And then can you show us some of the stuff that you did to configure the web app? Because you had to do something on the app service side, right?
Yeah. So if we go back to our web app, and if you remember from that slide, I noticed that, or I mentioned that there's 3 config values that you need to set. If you go to your configuration in your general settings, under platform settings, you'll see HTTP version and HTTP 2.0 proxy. So the first setting that you have to set to 2.0 will configure the app to allow incoming HTTP 2 request. And then the second one that you'll set to on is going to make sure that the front end forwards that traffic to the worker. And
so here's where we're seeing the actual changes that we did on the front end that enabled this traffic to flow.
yeah. And then there's one more that we have to do. It's set the application setting to this HTTP 20 only port. This makes sure that your app has a specific HTTP 2 only port that it's listening for, and that's how that connection is made. In our case, we have a value of 8585, and if you actually go to the log stream for the application, you can see that it's listening to 8585. So that's how you know that your gRPC server is ready to take requests.
So in this case, the ports that are publicly exposed are still going to be 80 and 443, but then as the traffic comes in, it gets routed to the local port, which is 8585 on the particular VM where the traffic is being received, correct?
Correct. Yeah, and
Awesome.
that's a port number that we define.
Cool. And then is there anything that you have to do on the client code or on the server code that was special for this scenario, or did just the templates that come in with Visual Studio, was that enough?
Yeah, so in this case, the server code was one that we use from a templated Visual Studio gRPC service. If it's your first time going through this process, you're likely going to use this template. And there's a couple things that need to be addressed. First, you'll go to your properties and launch settings, and you want to make sure that this launch browser property is set to true. And essentially, this is going to make sure that your browser is launched properly, and it shows us that initial message that your client needs to be a gRPC connection. So that's one thing that you need to do. And then the second one is actually in the app settings. This Kestrel configuration code doesn't need to be there. App service is already aware that your protocol is HTTP2, so you can remove that. If you left it in, it might cause an issue with your launched browser. So we like to comment that out. But that's all you need to do on the code side, and then you can deploy it to app service as long as you have those 3 config values set.
Awesome. And then you said that we support 4 of the scenarios. Can you show us another one?
Yeah, so we support server streaming, client streaming, and bidirectional streaming. We have a server streaming example that we can show. And here, this is a server streaming client that is currently pointed to a gRPC server stream app that's already deployed. And it's simple. It has a for each loop that just continuously keeps that connection open. So it'll send a request to that gRPC channel, and then the server will stream requests back. So let's go ahead and run it. Right. And so what's happening here is the client is sending a request through the channel. The gRPC server is then streaming replies over a single gRPC connection until that loop is finished. And the reply coming back from the server is hello from app service.
Awesome. So in this case, instead of making one request for every line there, we make one request and we let the server send back, whatever data as it's happening.
Yes.
And the benefit here is that I have less overhead, right? Because I don't have the overhead of establishing the connection, having the conversation, terminating the connection, then starting it again.
Yeah. Yeah, so that's the server call. And that's the end of this particular demo. If you want to use these code samples, we do have a link at the end of the deck that will have the link to the repo, so you can try these out yourself as well.
Awesome. So let me get the slide up, and then maybe we can show that.
Yeah.
And I think we have a couple of things here. One is we have the blog for gRPC with .NET that goes into a lot more detail than I can cover during a quick session. That's the heavy lift blog. We have the how-to articles that were written by Jeff, where you can go get the sample code and play with it. I guess one thing that we forgot to mention is this is currently supported only for if you're hosting your web app on a Linux. It can be either bring your own code or bring your own container scenario. Where we know that there's interest to support this on Windows. We need to do a little bit of work to actually update the OS on all of our Windows workers, and App Service is a huge service. It takes us a little bit of time to go roll that across the world. It's something that we want to do. It's in the backlog. We'll get there. And then we have the link to the App Service team blog. This is a blog that is put together by the actual engineers on the team. So you're getting the unfiltered real content here. And then finally, we have the App Service Twitter handle. You can use it to interact with us. And I'm going to take advantage. I'm going to plug in that we also have a tech community. A monthly community stand-up for App Service. We've had one episode. We have the next episode happening tomorrow. So follow us on AC App Service and get all the details about that as well. So with that, I think we can switch over to Q&A.
Awesome, thank you. So we have a lot of questions on why gRPC versus something else. So I can start just listing some if we want to talk about that. So we have why gRPC instead of WebSocket or just a normal conventional REST API.
So let's start with the REST versus gRPC. In general, I think they solve different scenarios. REST, the biggest benefit of REST is that it's human readable. So it's very easy for you to just curl something from the command line and see the conversation and see what's happening. The side effect is that it doesn't support streaming. It doesn't support the bidirectional streaming. And you have a lot of overhead of one request, one response. It gets complicated when you need to do batching, etc. So I would say if you're exposing an API that is going to be publicly consumed and you don't control the client, REST is a good idea if you're willing to pay the overhead of the conversation that is happening over REST. gRPC is more geared towards the better examples are the streaming and the bidirectional streaming scenarios where you don't want to have the overhead of the connection and you have a lot of data to move back and forth, and you control both the server and the client. That makes it so that it's a lot more efficient. You can throw more bytes over the wire that are actual payload versus the overhead of the connections. Jeff, I don't know if you want to add anything to that.
No, otherwise it's, if you have to communicate over HTTP2, that would be a scenario, or if you need, to get that higher performance.
Yeah, and on the WebSocket side, we do support WebSockets on App Service. I think the difference here is around the platform support that exists, and how easy is it to write a WebSocket application properly versus how easy is it to write a gRPC application properly. Honestly, I think perf-wise, they're going to be similar. I don't think there's going to be a huge difference going with gRPC, but the community support and the you're not alone when you're writing the gRPC app. I think that's what it comes down to.
We are putting the demo repo that Jeff showed into the chat as well, so you have access to that. But those are all the questions. If you all have any more questions, please put them in the chat, and we'll make sure we get to them. But thank you so much, Byron. And yeah, as you had mentioned, we will be having another live stream. So what can we anticipate learning tomorrow?
So that one's going to be a different direction from what .NET developers would probably expect. So we're going to be talking about WordPress and app service. So this is PHP. And WordPress happens to be one of the most popular CMSs in the world, and people use it to host and run large-scale applications. And being able to host WordPress on app service at scale and with an out-of-the-box configuration that will scale with your needs is basically what we're gonna go talk about.
Awesome. Well, we want to make sure that everyone gets a chance to go grab some coffee or take a 5-minute break. And so we're going to break for 5 minutes before we end our app development segment of .NET Day. Thank you so much, Byron. Thank you, Jeff, for the wonderful demos. This is awesome.
Thank you, everybody.